Alright, so we are going to look now at the examples, and we're going to use what we just saw up here, at least some of it, and up here. Alright, so for each polynomial A, state the degree and leading coefficient. So the degree, we'll call it n. You know what, I'll write degree. And leading, so the degree, and all I have to do is look at the exponent, right? The highest exponent is a 4. And the leading coefficient, is whatever the coefficient of that particular term is, -6. Okay, remember that's my A when I look at this over here. Okay, all right, so what have I seen? Well, for the degree 4, and this tells me the end behavior right here, degree 4, negative leading coefficient, which means this one. So I'm going to say f of x goes to negative infinity as x goes to negative infinity. And so that means this is on the left hand side. And on the right hand side, f of x goes to negative infinity as x goes to positive infinity. As x goes to positive infinity. What does that mean? Well, that means on the left hand side, this is drooping, falling. The graph is falling. On the right hand side, the graph is also falling. Let me focus in a little bit more. Okay, so an x to the 4 should be with a less than 0 should be falling. And if we look up here, an x to the 4th with a less than 0 is falling to the left and falling to the right. All right, let's start off number 2. So that was B right there, end behavior. Oh, oops, B. B was the end behavior. A was the degree and the leading coefficient. All right, so we want to find degree for A and leading coefficient. Which again we call A up here. That's our A up there. That's a leading coefficient. All right, so the degree, again, I look at the highest power. And leading coefficient, 0.4. Notice that's a positive, right? So A is greater than 0. So that means for the end behavior, I'll follow this guideline for the odd ones, and A is greater than 0. So f of x approaches negative infinity as x goes to negative infinity. Okay, that means that on the left hand side, y is at falling over here. And f of x approaches positive infinity as x goes to positive infinity. Okay, so that means y is climbing as to the right. Yeah, and in general, y is climbing to the right. It's going to be going up that way. Just might have a few turning points. Okay, in this case, it might have 6 turning points. All right, we'll leave number 3 for class, and we'll discuss these further also. All right, let's take a look at number 4 and number 5 here. We'll do number 4 and we'll leave number 5 for class. So this says here this is a graph of the polynomial function f. Let a be the leading coefficient. Determine the number of turning points and estimate any x-intercept. So a, determine the number of turning points. So turning points is where it turns from down to up or from up to down. So there's 2 places where it does that. 2 turning points. Okay. Notice it's just how many, right? 2 turning points. I'll write turning points just so we don't get confused. That's not x equals 2. It's 2 turning points. All right. And then it says estimate any x-intercepts, right? So the x-intercepts looks like -2, 0, 0, 0, and 2, 0. Okay. Remember the intercepts also tell us how many real zeros we have or solutions. Letter B, state whether A is greater than 0 or is less than 0. So because it's falling downward, yeah, A is less than 0. And letter C, determine the minimum degree of f. So that brings us back to what's the relationship between minimum degree and number of turning points. So remember our pattern over here. Where's the degree and the turning points? Oops, Yeah, the degrees over here are turning points. So if you have a degree 2, turning points is 1, and backwards, right? If you have 1 turning point, that's degree 2, 2 turning points, that's degree 3, 3 turning points, that's degree 4, at least, right? It could be more. So I have here 2 turning points, so the minimum degree would be 3. Okay? All right, and you will do number 5. Let's do number 6, and then we'll leave 7 and 8 for class. So number 6 says, sketch a graph of a polynomial that is degree 4 with real zeros and a less than 0. With degree 4 with 4 real zeros. Okay, so degree 4 with 4 real zeros. So we look at degree 4 and a is less than 0. Degree 4 looks like so, like a W or an M, right? This one is a is less than 0, and that is the M. A is less than 0, and we wanted to have 4 x-intercepts, 4 zeros, I mean, which corresponds to 4 x-intercepts. Okay, so I'm just going to draw an M. Does it have to be a nice looking M? No, sometimes they're lopsided like so. Okay, as degree 4, a is less than 0. Right? And notice that also follows this right here. Degree 4 with a less than 0, f of x goes to negative infinity as x goes to negative infinity. It's to the left it's falling, and f of x goes to negative infinity as x goes to positive infinity. That means to the right it's falling. So that's what we have here. To the left it's falling, to the right it's falling also. Right? All right, we'll leave number 7 and 8 for class. All right, that'll be the end of section 4.2.